That process of balancing the system is going to get you to a certain point down this landfill gas production curve. But eventually, your gas production is going to be so low that no matter how low you turn your valve down, you're going to be having too much atmosphere. Your flare is not going to have enough methane to run. It's not going to be appropriate to run this active system anymore. And this might come sooner into a system that is smaller than a bigger one. So one of those landfills that's too small. In that scenario, you want to switch to a passive landfill gas venting system. So while this does not allow you to destroy the methane or use it usefully, it still allows you to control some of those health and safety aspects and prevent your landfill gas from moving off-site where it can cause those flammability, toxicity risks. So passive landfill gas venting systems really focus on creating a high permeability layer that landfill gas can escape out of once it gets into. Just two conceptual designs. On the left here is a trench design. So we've got our landfill gas. The landfill would be on this side, and then there's just this lens of gravel buried. So once it hits the gravel, it's going to be easily able to dissipate along its pressure and concentration gradients, and it's going to be able to come up and out into the atmosphere. We've got a membrane here to prevent it from going further along. So this should push it up and out of the atmosphere, and then the concentration on this side should be very small. We can also add vents into this type of system. So rather than having a permeable surface, the surface could be a little less permeable, but then the vents would be the permeable element, and that could carry it above, like human height if you've got this in a public area and you don't want it kind of blowing in people's faces and things like that. You could also have systems, rather than having a continuous trench, they'll use columns that drill down into the waste and then would vent through a similar stack. Just ways of creating that high conductivity area for the gas to go and not having the gas find it more easy to keep moving sideways through the soil and into a structure or offsite. One kind of enhanced way of doing passive venting systems is employing biofiltration. So biofiltration refers to the use of microbes, which can actually oxidize a little bit of methane and maybe some other organics in the landfill gas and mitigate some of the odor and greenhouse gas implications of the landfill gas. So this provides a little bit of treatment without having to be running a flare. If you've got a really low concentration that you can't pass through a flare, it won't be able to burn it. Biofiltration would be better able to handle that low concentration of methane. And biofiltration can be done in a few ways. So in the picture here is a concept called bio window, where there's a few areas of the landfill that are engineered as vents that are lower permeability and will encourage the gas to flow out through them. And then inside those bio windows, there would be media that would encourage microbes to grow, which would metabolize the methane when it passes through. In addition to bio windows, you could have like discrete biofilters. You could have air being piped into them passively or even actively, and then have your microbes doing their job in that biofilter. Or you could even, instead of having these discrete units like the bio window or a biofilter, you could engineer the entire cover to perform this function of maintaining this microbiome. And that design is called a bio cover. So the whole cover is supporting these microbes that are going to be eating a portion of the methane that's coming up through the system.